In this section, we are going to discuss about the packet flow when we will use the static ingress replication. So let's take an example of communication between host 1, which is connected to leaf 3, port number 1 by 3, and host 5, which is connected to leaf 5, port number 1 by 3. So both the interfaces on leaf 3 and leaf 5, they are into VLAN 10. And you can see here VLAN 10 is a part of VNI 10.10.10. So let's assume that there is no ARP entry into the ARP table of host 1 related to host 5. Okay, so when if host 1 tries to ping host 5, because there is no ARP entry into the ARP table of host 1, it is going to, or it is going to find out what is the MAC address against the IP address of host 5. Or in other words, it is going to send the ARP request, right? So let's see what exactly will happen. So host 1 is going to send an ARP request, something like that. The source IP will be 10.1.1.3, right? Or 10.1. I'm just typing 10.3. The destination IP, it will be 10.5, right? Or 10.1.1.5. The source MAC will be the MAC address of host 1, which is 1111. And the destination MAC will be all zeros because uh, it is trying to find out the MAC address of host 5, right? Or the IP against the IP address 10.1.1.5. So this ARP request host 1 is going to send to leaf 3. So once leaf 3 receives this information, right? Because you see, this is the ARP, this is our payload, this is the ARP request, and at layer 2, ARPA is going to put the source MAC and the destination MAC as OLEF, the broadcast MAC. So once leaf 3 receives this particular information at layer 2, because leaf 3 received the bump traffic, and we already configured the static ingress replication under the NVI interface for VLAN 10, or you can say that VNI 10.10.10. So now leaf 3 needs to replicate this traffic, or needs to send this particular bump traffic to all the peers that are configured for static ingress replication. So in our scenario, we configured the static ingress replication for peer or leaf 4 and leaf 5 both. So leaf 3 is going to create two copies, one for leaf 4 and another for leaf 5. So we will discuss about the copy that it is going to create for leaf 5, because we are taking an example of leaf 5. But similarly, it will also create the copy for leaf 4. So now leaf 3, before sending this bump traffic into the fabric, it is going to put some information related to VXLAN, right? So it will put the inner source MAC address, which will be same as received from the host 1, which is 111, and the destination, inner destination MAC, it will be OLEF, right? Because it is a broadcast frame. Now into the VXLAN header, it will put the VNI information. So VNI information is 10.10.10. Now we have the UDP header. So there will be a random source port, anything, let's say 15010. To perform the ECMP, it use the random source port, and the destination port will always be 4789, which is reserved for VXLAN. Okay. Then we have the outer IP header. Into the outer IP header, it is going to put the source IP. The source IP will be the tap address of leaf 3, which is 3333, and the destination IP is, let's say we are trying to communicate to 555, it will put 5555. Now we have the outer MAC header. Into the outer MAC header, there will be simple layer 3 device logic that the source MAC will be the exit interface MAC, which is 3131, and the destination MAC will be the next hop MAC or next hop interface MAC. So the next hop device is spine 1, and it is having the MAC address of 0011 for interface 1 by 1, which is connected to leaf 3. So the next hop MAC will be, or the destination MAC will be 0011. So this will be the full packet that it is going to generate, and it uh, it is also going to generate another packet which is for leaf 4. For leaf 4, you can see that all the information will be same except the um, outer IP header. Into the outer IP header, the source IP will be same, but the destination IP in case of leaf 4, it will be 444. So now this particular information, it will go to spine 1. Spine 1 is going to modify the outer MAC header, right? So the outer IP header will be same, and like a layer 3 device, it is going to modify the outer MAC header. Into the outer MAC header, it will put the MAC address of its exit interface as source MAC. So the source MAC of interface which is connected to leaf 5 is 0013, and the destination MAC will be the next hop MAC address. You can see the next hop uh, for spine 1 is leaf 5, right, which is 5555, and the next hop interface MAC is 5151. 5151, simple layer 3 device logic, right? Before sending the packet to the next hop device, the source MAC and destination MACs are going to be changed. Now this particular information will be received by leaf 5. Now you can see that because the destination MAC is 5151, that is why leaf 5 at layer 2 is able to accept this particular frame. Otherwise, if spine 1 does not modify the destination MAC, leaf 5 will never accept this particular frame at layer 2. That is why it is important for layer 3 devices to modify the outer MAC headers. Okay. So now leaf 5 will accept this particular frame, and you can see that into the source IP, it knows that this particular packet, it comes from leaf 3, and the destination IP is the leaf 5 itself. And you can see that this particular packet is for VXLAN. You can see the destination port is 4789, and it also knows that this is the VXLAN head. Into the VXLAN header, it is this particular information is for VNI 101010, right? Into the inner source now you can see that based upon the inner MAC header, you can see that we have the inner source MAC and inner destination MAC. So inner source MAC is 111, so it is going to save this information that 111 MAC address, right? It is behind which device? It is behind leaf 3, which is having the VTAP address 3333, right? Also, when leaf 3 received the ARP request from host 1, it is also going to save this information that MAC address of host 1, it received from Ethernet 1 by 3. Okay. So now leaf 5 saved this information based upon inner source MAC, and based upon the inner destination MAC, which is the broadcast OLEF, or it is a broadcast frame, it is the bump traffic. So leaf 5 is going to flood this remaining payload or this ARP request to all the interfaces that belong to VNI 101010 or VLAN 10. So you can see that on leaf 5 we have Ethernet 1 by 3, which belongs to VLAN 10. So this ARP request will be flooded to host 5, right? Now host 5 is going to save the information about MAC address of host 1, right? So now it knows that 1111 MAC address belongs to 10.1.1.3, right? So now leave 5 sent the ARP request to host 5. Host 5 received the ARP request. Now it saved the information into its ARP table related to the MAC address against the IP address 10.1.1.3. Now host 5 is going to uh, send the ARP reply packet. Into the ARP reply, it is going to put the source IP as the IP address 10.1.1.5, or let's simply say 10.5. The destination IP will be 10.1.1.3, right? And the source MAC will be 5555. The destination MAC will be the MAC address of host 1, which it already received in the ARP request, which is 111. So this particular ARP reply will be sent to leaf 5, and again into the layer 2 header, or the ARPA is going to put the source MAC and destination MAC before sending this ARP reply onto the wire. So the source MAC will be the MAC address of host 5, which is 5555, and destination MAC will also be same like the host 1 MAC address, which is 1111. So leaf 5 is going to receive this particular information. So it is going to save the MAC address that it received into the frame that is sent by host 5. So now it knows that 555 for host 5, it lies behind Ethernet 1/3. And now it will check the destination MAC. Into the destination MAC, there is 1111. Now you can see that already the MAC address of host 1 is populated into the VNI table of leaf 5, right? It knows that 1111 MAC address, it lies behind leaf 3. So directly it can encapsulate the uh, packet, because you see that because leaf 3 received the broadcast frame, so it needed to send this information to all the devices that were configured under the VNI 10.10.10 for ingress replication. But now leaf 5 received a unicast reply, because our reply is unicast, right? So leaf 5, based upon the information that it saved, it can directly send the packet to leaf 3. So now let's see how the packet will be created by leaf 5. So let's put it here, and let's try to modify this information. So you can see here, let's delete this. So the source MAC will be, the source IP will be 10.5, destination IP will be 10.3, source MAC 5555, destination MAC 1111. So this was the payload or the ARP reply. Then into the wait a second, into the inner source MAC, the MAC address or the source MAC will be the MAC of leaf 5, right? Okay, let me clean it a bit. So the inner source MAC, the MAC address will be the MAC of host 5, which is 555. Destination MAC will be the MAC of host 1, right, which is 1111. The VXLAN header, the VNI field will be 10.10.10.10. UDP header source port will be random. I'm not modifying it, so you can just think of a random source port that it is going to put here. The destination port will be same 4789, which is reserved for VXLAN. Into the outer IP header, there will be the source IP of, there will be source IP of leaf 5. So this will be reversed, right? So the source IP will be IP address of or VTAP address of leaf 5. The destination IP will be 3333, which is the VTAP address of leaf 3. Now into the outer MAC header, again we have the same logic. The source MAC will be the outer MAC or the exit interface MAC for leaf 5 interface, which is connected to spine. So the MAC address will be 5151 and 0013, which is the MAC address of next hop or the spine interface 1/3, which is connected to leaf 5. So this particular information now, this will be received by spine here, right? And now spine again, it will do the same thing. It is going to modify the outer MAC header. So it is going to put the source MAC as the MAC address of exit interface, which is 0011. And the destination MAC will be the next hop MAC. It is 3131, which is the interface MAC of leaf 3, which is connected to spine 1. Now this particular information will be received by leaf 3. Okay, this portion is erased. So you can see here it was 1111 earlier, right? So this information will be received by leaf 3, and you can see that the destination MAC is 3131. So at layer 2, leaf 3 is going to accept this particular frame into the source IP. Now it knows this particular packet is sent by leaf 5 into the destination IP. It has 3333. So now you can see that this particular packet is for leaf 3, and it is for which protocol? It is for VXLAN, right? And this particular packet belongs to VXLAN, and I mean the VNI 10.10.10.10 into the inner source MAC. It has 5555. Now leaf 3 is also going to save this information that 555 MAC lies behind leaf 5, which is having the VTAP address of 5.5.5.5. Now it will check the inner destination MAC, which is 1111. Now you can see it already has the entry 1111. It knows where to send this particular packet. So the remaining information or the ARP reply leaf 3 is going to send to host 1, right? Now host 1 knows, or it is going to populate its ARP table that the MAC address against the IP address 10.1.1.5 IP address is MAC is 555555. Now it can properly ping host 5, right? So now the flow will be same. Okay, so when the next packet comes in, you can see that host 1 now can directly send the packet. The source IP will be 10.3, destination IP will be 10.5, source MAC 111, destination MAC 555. So now leaf 3 will receive this particular information, and into the inner source MAC it will put the source MAC of leaf of host 1. So here it will put 1111. In the inner destination MAC it will put 5555. So it is not going to change the layer 2 header that it received from host 1. Okay, so into the VXLAN header, no information changed. Now into the source IP, outer IP header, the source IP will be 3333. Destination IP will be 555, because you can see that it already has the information that MAC 5 MAC 5555, it lies behind 555, so it can directly encapsulate this particular payload into the VXLAN and it can send it to leaf 5. The rest of the information will travel like we discussed. Into the outer MAC header, there will be the exit interface MAC and spine interface MAC address. Okay. So this is how the Ingress replication is going to work, right? Similarly, leaf 3 is going to replicate, or it is going to create one packet for leaf 4 also, and the packet flow will be same. Okay. I hope that the packet flow is clear now for static ingress replication. Thanks for watching.